So today we'll be focusing on the trig ratios, and these ratios are the ratios of the sides of a right angle triangle. And by the way, very importantly, these ratios only apply to right angle triangle. But before I discuss the ratios, it's very important we know the labeling for the sides of a right angle triangle. So we have what we call opposite, adjacent, and hypotenuse. Now in the previous videos we looked at the hypotenuse when we were looking at Pythagoras theorem. But the opposite and the adjacent probably is an entirely new concept for you. So the opposite, remember the word opposite. Opposite is what we call a comparative adjective. Just like taller or shorter. If you say Mr. Brown is taller or Mr. Brown is shorter. Shorter than who? In the same way we use the word opposite. If you say in a line is opposite, opposite to what? Alright, so when we use the word opposite, it's opposite to a reference angle. So for example, in the image on the screen there is theta, the unknown angle. You see the side labeled in blue, opposite. So in that case, the side labeled blue there will be opposite. If you are referring to the angle, theta there. But let's say you have another right angle triangle. Forgive the poor drawing. And let's say this is theta, the angle you are referring to. Then which side would be the opposite side? You're correct. This side would be the opposite side. Because this side is opposite to the angle you're referring to. In this case is theta. And the hypotenuse h is always the longest side. The hypotenuse is always the side that is opposite to the right angle. And of course, we're left with adjacent, the side which is adjacent to theta. So it's very important for us to understand that concept, opposite and adjacent. So opposite, as I said, is a comparative adjective, and therefore, when you use the word opposite, it's not a fixed. So it's not a fixed side. It depends on the angle you are referring to. So let's say you have so in this case, let's change the color here. So in this case, if you're referring to this angle, then this is the opposite side. But if you were referring to this angle here, suppose this was the angle you're referring to as theta, then this side would be your opposite side. And the adjacent will switch places. And of course, the hypotenuse is always the hypotenuse. It's always the longest side. It's always the side that is opposite to the right angle. Now, I want to discuss the ratios. There are 6 of them. There are 6 ratios. But for the CXC, we only look at 3. Alright, sine, cosine, and tangent. And for this purpose, for this lesson, we're going to be focusing on these 3 ratios. Alright, the sine, the cosine, and the tangent. Now, this is how I remember them from high school days. So, ka, to. So, ka, to. That's what I use. And up to this very day, that's how I remember them. So, ka, to. Sine is the opposite. And by the way, when it's a sine, we sine of the angle, the reference angle. In this case, the reference angle in question is theta. Alright? Reference angle in question is theta. So, sine of the angle theta is the opposite side over the hypotenuse side. So over A, O over H. Alright, the OH mean O over H. Ka, the cosine of the angle, reference angle here, cosine theta, is the adjacent side over the hypotenuse side. So ka, the AH, means adjacent over hypotenuse. And the tangent, tan theta, toa, OA means the opposite side over adjacent side. So ka toa, sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. Right? And by the way, just for information's sake, these others, cosec, sec, and cot, these we get from reciprocating these original ones. So we get cosec from reciprocating sine, we get sec from reciprocating cos, and we get cot for reciprocating tan. Alright, but we won't be focusing on these any at all. Our focus will be on these three. Right? So, to sine, opposite over hypotenuse, cos, adjacent over hypotenuse, tau, opposite over adjacent. So let us now try to solve a few problems using these ratios. So let me just put them up here. Remember, we have a three of them. We have so, and we have ka, and we have to. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So in this question we are asked to find the value of x. Alright, so we are asked to find the value of x. Now, remember when it comes to right-angled triangles, so we have two tools in our toolkit. We have Pythagoras theorem, which applies only to right-angled triangles, and we have the trig ratios. Now remember there's three basic trig ratios: sine, cos, tan. The question always arises, which one of these ratios do we use? Which one of these ratios do we use? Do we use the sine ratio? Do we use the cos ratio? Do we use the tan ratio? Or can we use Pythagoras theorem? No. Before we even get to the ratios, can Pythagoras theorem be used? No, it can't. Remember, for Pythagoras theorem to work, you have to have the length of two sides, and then you want to find the length of the third side. So in a case like this, Pythagoras theorem will not work, because as it stands, we only have the length of one side, and therefore we have to turn to the trig ratios. The question now arises, which ratio do we use? And the ratio you use depends on the information that you're given and what you are being asked to calculate. Now, what information are we given about this triangle here? And everything, when I say information, in reference to this angle here, 60 degrees. Right? So into this angle 60 degrees, the 13 would be what? You're correct. The 13 is the adjacent. Let me just put A. So you're given the adjacent. I put A there. And what are you being asked to find? You're being asked to find x. X would represent the what? Opposite. So in the context of opposite, adjacent, and hypotenuse, this is always the hypotenuse. The hypotenuse side is always the side that is opposite to the right angle. Alright? So this is your hypotenuse side, H. This is your opposite side. Why? Because we are referring to the 60 degrees angle, and this x here is opposite to the 60 degrees. And the base would represent the adjacent side. So of course, you're given the adjacent and you're being asked to find the opposite. So which ratio has opposite and adjacent? That's a tan. So katoa, right? So we're using the tan ratio. Let's use the tan ratio. The tan ratio says tan theta. So tan the angle. What angle are we talking about in this question? 60 degrees. So tan 60 is equal to opposite over adjacent. What's the opposite? X. And what's the adjacent? 13. So now we need to transpose for x. And if you have been following my channel, you all should be experts at transposing now. So here we have an equation with a denominator of 13. So we need to get rid of this 13. So how can we get rid of the denominator? Good, we'll multiply both sides by 13. So 13 times the left hand side and 13 times the right hand side. And you see exactly what happened. On the right, 13 into itself. So 1x, which is just x. And then 13 times tan 60. Let me just get my calculator. And you will want to put your calculator in degree mode, since we are working with degrees. So make sure your calculator is in degree mode or D mode. And you press 13 tan 60. And I have here 22.5 if I should use one decimal place. So 22.5. I'm using one decimal.